Hey guys, today I'm going to make a new video because the original 2.5, 2.6 didn't come out. So I'm making another one for you today. And it's on section 2.5, 2.6, Beginning Algebra. And because I don't have my packet on me, I'm going to be working them out on paper. And then what I'm going to do is toggle back and forth to my screen share so that you could actually see the problem I'm going to be working on. For instance, 2.5 first, and then I'll go back to my document camera and work out the problem. So here we go. So what I'm looking at is here. Let's see, are you seeing that? I think you are. So what I'm looking at here, what I'm looking at here is your Math 150, the 2.5 on the word problems, the applications. This is an introduction. You'll see applications later on in the course towards the end in chapter 4. But right now, these are some word problems. Get you started thinking about it. A couple thoughts through this. If you would identify what your variable is, and the variable is usually the letter that you get to pick, like the letter X is the most common one. You can pick whatever letter you want. And then when I'm looking here, you want to identify what the variable represents. So for most of them, I'm going to do that. You want to create your equations, which will be the most challenging part of this, always is. Solving should not be too bad right now because the process, you should have been practicing this and the process looks pretty familiar. And at the end, you get a solution. You'll get like X equals. But I like the answer in a sentence of some sort. So in the multiple choice, what you'd expect is they might say, hey, what are you going to let your variable represent? Letter A, letter B, letter C, in terms of choice on multiple choice. It might say, what equation might best look? And then the other one would be, what's the solution? Here's the word problem. What's the solution? And oftentimes in words. But you got to get there by the algebra to get to that answer. All right, so I'm going to share my screen on this one. So you'll see, by the way, our first problem we're going to be looking at is number 1. And it talks about this number, 28.6, is what percent, now we're talking about percentage, what percent of 52? Now, if you think about half of 52 is what, 26? Half is 50%. 26 this is a little bit more than 50%. So the answer ought to be a little bit more than 50%. So what I'm going to do is a very simple equation that I'm going to set up. Let me go back to my share screen so I can show you what I'm going to be writing on. Give me a second here, back and forth. So it says what? Now you're going to have to look at your packet because what I'm going to do is write here, right here. So what I'm going to have is X equals, this is number 1. And I see as it asks for what percent. So you might say X equals the percent. And then it says the number. So then here's my equation. That's like step 1. And then I have my equation that would be the number 28.6. The word is oftentimes is the equal sign. The word is and the equal sign go together. Is what percent? That would be your X percent of, usually or oftentimes the word of in applications oftentimes mean multiplication. So the word of oftentimes means multiplication, like the multiplication dot is what I would use. So times, so what percent of looks like 52? And then the algebra then after this is getting the X by itself. So you're going to divide both sides by 52. So 28.6 divided by 52 equals X. And if I take my calculator and look at that, and if you give me a moment, I'm going to show you. I'm going to take your calculator. And take 28.6 and then divide that by 52. And then you're going to get a number, but that's not the percent. That's the decimal version of the percent. So remember, you always change a decimal to a percent by moving the decimal over 2 places, in this case to the right. So it looks like it's 55%. X equals 0.55, but X equals 55%. So 55%. Or you can say 28.6 is 55% of 52. Either way is good. Okay, number 2. It says the number, now if you want to say number 2, you can see this on your packet. I'll just speak it out on this one. And sometimes I'll share my screen and show you what I'm looking at because I need to take a look at it too since I don't have my packet on me. It says the number 126 is 35% of what number? So the word is equals, I see this as X equals the number because that's what they're asking for. What's the number? So X is the number. And then you can say 126 is, that's like the word is, 35% of, that's like the word of, and then it says what number. And so then what you're going to do then is you're going to divide both sides. I'm going to get the X by itself. Divide both sides by 35%. Of course, then I would probably change 35% to a decimal. And then I get the following. Use the calculator. 126 divided by 0.35. 126 divided by 0.35. 126 divided by 0.35. Okay, 360. So that means 126 is 35% of 360. 50% would be what, 180. So 35% ought to be lower. See, 126 is lower than half of that, 50%. So it feels like it's on the right track. So I'd say the answer then is 360. 360 is the answer. So the number is the 360. All right, let me show you what the next one looks like. We'll read that one. Okay, this used car dealership, okay, they wanted to reduce the price of a used car by 8%. So the price of the car before the discount was $18,500, and they want to make it go lower. And so they want to know what the discount is, the amount of the discount, and then what's the new price. So instead of maybe sometimes creating an equation, sometimes the common sense comes in. So I'll just do this. Watch, I'll put this in my screen share. Sorry, back and forth. It takes me a little time and I get a little pause in there. All right, so this is number 3. Original price. Less discount equals new price. So, but what it is, the original price right here is $18,500. Now, the discount is 8% of, that's multiplication, So 8% of the original price. So maybe parentheses. And that equals your new price. So maybe that's your X. That's your new price. Now, if you want to know what the discount is, that's part of the problem. You're going to take 8% times that. Now, remember, 8% is the same as 0.08 times 18500. Yeah, 8% as a decimal, move it to the left. Okay, here, move it to the left, 1, 2, and oops, you don't have enough spaces, so you put a 0 in its spot and put a decimal right before it. So 0.08 times 18,500. So there's your discount, 1480. So here's 1480 is your discount. You have 18,500. And then what you're going to do is you're going to end up, so this is your discount. That's the answer to one of them. And then your new price would be the difference between those. So you got 18,500 and subtract 1480. And it looks like I got $17,020. $17,020. That's your new price. Okay, next problem. Okay, let me get back over here and see what the next problem looks like for you guys. Okay, this one here, it says the difference, so that's a subtraction. The difference of a number and 4 is doubled. So the difference of these two things are doubled. The result is, now it's another phrase for equal signs. The result is, so that means equal, 16 more than, that means you're adding 16 than whatever the number is. So let's say X is the number. X is the number. I guess this is number 4. X equals the number. And it says the difference of the number, that number, and 4. So that means you go X minus 4, and that whole thing is doubled. The whole thing. That's a little tricky on that, but it's the whole thing. It's just not the original number. It's the difference that's doubled. The result is 16 more. So you're adding 16 to the number. And it says find the number. So now it's just the algebra to get to the what X equals. So I see it as 2X subtract 8 equals X plus 16. And then I'll decide to move over the X to the left-hand side. So subtract X. So I get X subtract 8 is equal to 16. And then you're going to add 8 to both sides. So it appears to be 24. So again, the difference of a number, difference of 24 and 4 is 20. If that's doubled, that's 40. It's the same thing. So if the difference of the number, here's the number, and 4 is doubled, so 20, 40, it's the same thing as this number added with 16, which is still 40. So it checks out. Okay, number 5. Now in your packet, I'll just leave it there. Number 5 indicates you got a piece of lumber and you're going to cut it in a certain way. So here's your piece of lumber. You're going to cut it like right about there. So one's a short piece and one's a long piece. Let's call this the short. And this is long. And so it's going to cut it into 2 pieces. So the longer piece, this one here, is a foot more than 3 times whatever this one. Here's the short piece. So maybe we let x be the short piece like this. And the long piece right here is a foot more. So you're adding a foot more to 3 times the longer. So 3 times this and a foot more. And then altogether, it's 21 feet. Altogether, it's 21 feet. So the equation then comes from this, is these 2 pieces of the board is equal to 21 feet. So that means the equation is x plus, that's the short, plus the 3x plus 1, that's the long, is equal to 21. And then we're going to combine like terms and solve for x. So this would be 4x plus 1 is equal to 21. And then solve for x. So then we get 4x equals 20. And x is equal to 5. So what's 5? It's the short piece. See, x is the short piece right here. So it asks you what's the length of both pieces. You'd say the short piece is 5 feet. And the longer piece is, well, it's got to make up 21. So it's the leftover between 5 and 21, 16. Or you can put in 5 right here. 3 times 5 is 15 plus 1 is 16. So 16 feet. Okay, let's take a look at another one. Okay, let's see, number 6. So on angles, that looks like a right angle. So if you have 2 angles and you add them together, they form 90-degree angles. That means they're complementary. You can see up here, complementary angles. That means they add up to 90 degrees. So you're supposed to find the measure of both. So let's see. Over here, show you what this is. Basically, you take these 2 pieces and add them together to give you 90. Let me stop share. Let me get back into my advanced, which is doing the work. So this is number 6. All right, so the 2 angles, you've got x degrees. I'll drop off the degree market. I'll just say x and then plus, and then 2x subtract 3. And that equals to 90 degrees. Again, I'm just dropping off the degree marker. At the end, you need to include the little marker or the word degree. And okay, just let's combine like terms. So you got 3x subtract 3 is equal to 90. You got 3x is equal to 93. And you divide by 3 and you'll get x is equal to 31. So you say the angles are 31 degrees because that's what the smaller angle looks like. So angles are 31 degrees. And okay, so now you need to make up the leftover between these 2 right here. You can subtract them, or you can put 31 in this and come up with your result. I'll do that. You can take 2 and 31, subtract 3, and this will give you your leftover, which is what, 62 subtract 3, 62 subtract 3, 59 degrees, 59 degrees. Okay, let me unshare that one. All right, well, there's your 2.5. It looks like that's what I have for 2.5 for you guys on those pages, at least in my packet on the computer. So it shouldn't be any different for you. And the few problems that I've given you will feel similar, but they'll be different in some respect because, you know, not every one is not exactly the same. Now the next section, which is 2.6, this is number 2.6, and you're going to see me do that in a second, deals with basic formulas. And if I scroll down here, you'll see basic formulas. Distance equals rate times time. You've heard that before somewhere. The formula of the perimeter of a triangle right here. And then a rectangle, and for sure, you've seen the formula for the perimeter. That means you're going to go all the way around a rectangle. So you add up all the sides. So what we're going to do is we're going to end up taking each formula, and I'm going to solve for the letter that's being asked for. You're not plugging anything and then in on these particular problems. So let me go share my screen and we'll do number 1. So in number 1, you have D equals RT, and it asks for to solve for the letter R. So I'll underline. No, I won't underline. I want to get R by itself. So I'm going to get rid of the T. Remember that? Get rid of the T because this is a multiplication. So divide both sides by T. And what you're left with is D over T is equal to R. And that's what we are trying to do, is just get the letter by itself that they're asking you for. I'm asked for the letter R. And that's it. Okay, in your packet, number 2. Number 2 has P equals A plus B plus C. And it looks like they're asking, or I'm asking you to solve for the letter C. So I want to get this by itself. So these two need to move over. You move B over by subtracting B. So P subtract B equals, so I'm sorry, P, let's do this. All right, so subtract B from both sides. You got P subtract B is equal to what's left over is A plus C. And then subtract A and subtract A. And these are not like terms on this side. So we go P subtract B subtract A. And the only thing left on the right-hand side is the letter C. Okay, number 3. You got the letter P equals 2. I'll make that capital L and then plus 2 capital W. And I'm asking you to get the letter W by itself, this one here. So the first thing I'm going to do is get rid of the 2L. I'm going to move that over by subtracting 2L to both sides. So you get P subtract 2L is equal to 2W. And then I'm going to go ahead and divide both sides by the 2. So get rid of the the 2 by dividing by 2. And you get P subtract 2L all over 2. Now that's one version of the answer, which is very acceptable. In the back of the book might even have that. The other version could be split this up into 2 fractions. So this works. The other version could be P over 2 subtract 2L over 2 is equal to W, or P over 2 subtract L is equal to W after you reduce like that. So that's another version. Either one for me, it doesn't matter which one you pick. It works for me. All right, let's take a look at the next problems here. Number 4. Number 5. Okay, so it looks like I'm trying to get number 4, the R by itself. So I'm simply going to divide both sides by 2 pi. Over here, try to get the pi by itself. And again, just divide by R squared. So 2 pretty simple ones. And I'll show you what that looks like here. So number 4, capital C. Now capital C stands for circumference, 2 pi R. Of course, pi as a number is around like that, 3.1428 and so on. It's not exact. Do not say pi equals 3.14. Don't do that because that's not true. It's about that. Anyway, we're just going to move this over both sides by 2 and the pi, because I want to get the r by itself. So 2 and the pi. So there you go. C over 2 pi is equal to r, and you're done. And then number 5, you want a equals pi r squared, and you want to get the pi by itself. So divide by r squared, by r squared. And again, we are done by going pi equals a over r squared. So those two are pretty straightforward. If you get the idea that you're trying to solve for one of the variables and you're just doing the algebra, add, subtract, multiply, divide. In this case, it was divide. Okay, let's see what the next ones show. Okay, so the next one, number 6, 7, and 8. I'm going to do 8 slightly different. So I'm going to modify 8 instead of solving for m. I'm going to do something a little different. But 6 and 7, I need to get letters B by itself and letter H by itself. And the idea is, gosh, it looks like this is all being multiplied. So divide. Same thing here, all being multiplied. Again, divide. So I'm going to do 6 and 7 first. 6 and 7 first. Number 6 has the A equals a half times BH. Now this is the formula for the area of any triangle. Okay, now get rid of a fraction. You could divide by a fraction, but it looks kind of weird like this. So you divide A by a fraction by 1/2, you'd probably mess that up. You know, if I divide by a half over here, it's gone. So BH, yeah, I'm not going to do it that way. I think you're going to mess that up. I'm going to say multiply by the reciprocal of 1/2. Now the reciprocal of 1/2 is 2 over 1. Like that. Multiply by the reciprocal of 1/2, and then this goes away. So you're left with BH, and over here, 2 times A. Remember, you multiply straight across. 2 times, there's a 1 right here. 2 times A over 1 times 1. Okay, 2A. And then get rid of the, let's see, we are wanting to isolate the B. So get rid of the H. Get rid of the H, get rid of the H. So in this one, you got 2A over H is equal to B. Okay, next one I'll do on this page over here, number 7. B equals LW, I'll make that an L, not a 1, LWH, LWH, and we're supposed to get the variable by itself, the letter H. So get rid of the L and W again by dividing. So B over LW equals H. Now, number 8, I'd said I'd do slightly different than what's in the instructions are there for. I'll show you what I mean. I'll write it out. It's Y equals MX plus B. Doing slightly different. Doing this. So let's say I give you the letter Y. Let's say I give you the letter X and the letter B. Let's say I give you those. Let's say I say, let's see, Y is equal to, let's go 20. Let's say X is equal to 3 and B is equal to 7. Let's say I did that. And I say, find M. Find M. No. So you plug it in and solve for M. So we'll go and say right here, this is 20. M is all by itself, dot. X is 3. Kind of looks a little weird, but we'll change that. And then 7's over here. I'll rewrite that because it looks a little on the weird side. So 20 equals 3m plus 7. And now I'm going to get the m by itself. That's what I'm solving for m. So 20 subtract 7 is equal to 3m. That would be 13 equals 3m, thereby getting rid of the m, excuse me, 3, divide by 3. And I end up with m equals 13 over 3. 13 over 3. Okay, let's see what else you got. Okay, 2 more problems, and then we're done with 2.6. 2 more problems. And that'll be it for today. Okay, let's share our screen one more time. So I look at these 2 problems. Again, they're formula problems, and then I'm just going to write them down and try to get the letter by itself that I'm asked for. All right, so let's go and do this. Back to document camera one more time. Okay, the first one, flip this over this way. The first one, which will be 9, is A equals P R T plus P. So I'm going to get the T by itself right here. I'm going to move that P over first. Let's see if you can see that. I'm going to move this P over first by subtracting P to both sides. Yeah, here's the equal sign. What I do to one side, do to the other. You don't subtract it from both those pieces, just one piece. So I'm left with A subtract P is equal to P R T. And now your job, according to the problem, I'm asked to go ahead and get the T by itself. So this is multiplication, multiplication, divide both sides by the P and the R. So I have A subtract P over PR equals T. And then finally, number 10. So you got capital S. This is surface area, it looks like. So capital S is 2 pi RH plus 2 pi R squared. And so what I'm going to do is I'm going to go ahead and this is asking for me to solve for H. So I'm going to leave this alone and move this whole thing over to the left-hand side. So subtracting 2 pi R squared and subtracting 2 pi R squared. So I'm left with S subtract 2 pi R squared is equal to 2 pi RH. And again, all of this right here is being multiplied. So get rid of it by dividing both sides by that, both sides. And then you are finished. So H equals the left-hand side. It's a big mess, but you're done. So if I asked you, or if I gave you the letter S, the letter R, you plug in those values, and of course pi is just a number in your calculator. You can grind this out and you can find whatever H represents, which is the height of something. Height of something. Okay, so there you have it. We are finished with 2.5 and 2.6. The very last section that you have is 2.9, and that's in another video. Okay, good luck. Have a good rest of the semester. Keep plugging. You're getting close to your first exam, and do the best you can. All right, later.